Hello, in today's video we'll be discussing Physics 253 Week 1, problem number 34. In this problem, we are asked to find a few properties of a honeybee that acquires an electric charge and is flying in the Earth's electric field. So for this problem, there's a few things that we want to note before we get started. As you can see, I've underlined some of the givens that I believe are important to solving this problem. As you can see, we have the weight of the honeybee, we have the charge of the bee, and then we also have the electric field near the Earth's surface. So from this, we can go ahead and draw a diagram. In this diagram, we have our electric field directed downward, as well as our force due to gravity. And I've decided to draw the bee as having almost like an electric field going off of it in the positive direction, because again, it's that plus 20 picocoulombs. And yeah, so let's go ahead and note down a few things that we need to do this problem. So we'll go ahead and start off with one of the more obvious ones. This right here is going to be the conversion between picocoulombs and coulombs, which we'll need for this part. And then we're also going to have force due to gravity, and this should be squared, excuse me. And then we also have the force due to the electric force, if you will, and the force due to gravity here. And to start off this problem, there's three parts of this problem. The first part, we have the ratio of the electric force on the bee and the bee's weight. And in the answer of this problem, we're given this ratio right here. So we know that this ratio is what we're solving for. So we can go ahead and substitute the values that we have here. Q being our charge and E being the value of our electric field, which again is going to be the Earth. And then we have the weight of the bee and the acceleration due to gravity. And we can solve for this, and I believe we get like 1.8 times 10 to the negative 8. But in this, negative 6. But in this case, we have rounded to significant digits to get 1.7 times 10 to the negative 6, and this is going to be a unitless number because it's a ratio. And for B here, what is the electric field strength that would allow the bee to be suspended in the air? When the bee is suspended in the air, there's going to be no forces acting on it, so the pretty much the force in the y direction is going to be 0, right? So we can set the values of the charges equal to each other, or we can set the values of the electric force and the force due to gravity equal to each other, and then we can rearrange to solve for the value of the electric field. So by doing this, again, after rounding to significant digits, we get that it's going to take a 5.9 times 10 to the 7 newtons per coulomb. And so for this suspension problem, we're also asked in what direction would allow the bee to be suspended in the air. And if the bee is going to be suspended in the air, so already in our normal Earth system, we have the our force of the electric field pointing downwards. And the bee is having to fight that as it flies, right? As well as force due to gravity. If the electric field, however, was going upwards, then the bee would just be able to kind of float. Or I guess the charged bee would be able to float. And just kind of be suspended. So I hope you guys found this problem helpful. Thank you very much for watching, and have a great rest of your week.